All right, ladies and gentlemen, here we go. We're going to make this quick and simple. Well, not simple, but quick. Basically, we're finding missing sides of special right triangles. We're finding exact answers, meaning no decimals, by using a couple formulas we know. The first order of business that you need to be aware of is that we have to understand how this part works. Sorry, I need to change to my pen here. This right here, okay, we do not want square roots in the denominator. So we do something called rationalizing them. To rationalize them, it's very simple. You choose the denominator and you simply multiply it by itself. And you do the same thing that you did to the bottom to the top. And when you do that, you get the square root of 10 times the square root of 10, and that's going to be the square root of 100. Now 5 is outside, 10 is inside, so you keep them outside and inside, just like that. But the square root of 100 turns out to be 10. So the square root of 10 times the square root of 10 is 10. So it eliminates the root for us. We have 5 square roots of 10. Now the 5 and the 10 are both outside the root, and they both simplify to 1/2. So this is 1 over 2. 10 and 2 simplify, but one's inside the root, one's outside the root. So you keep them separated, and that is a rationalized denominator, square root of 10 over 2. Now, here's one of the definition triangles. You're probably going to want to take this time to actually write this down in your notes. You're going to need to see this. It's on the formula sheet as well. But what's going to happen with this is that these 45, 90-degree triangles always have these ratios where the legs are both the same, so we call them x. And the hypotenuse is always square root of 2 times the leg. So if this leg was 10, this leg would be 10. And this leg would be 10 times the square root of 2. And it gives you an exact answer, and it's true all of the time. So make sure you write that down. That's one of your definition triangles. The other one is this one, 30, 60, 90. What happens here is the 60-degree leg is your short leg. It's always x. The long leg is the 30-degree leg, and that's always x times the square root of 3. And the hypotenuse is always 2 times x. So if this x were a 5, then this would be 2 times 5. It would be 10. And this would be 5 times the square root of 3. No decimals, exact answers. We're going to use these two triangles in about 7 examples to show you how to take some simpler ways. This avoids decimal answers and avoids Pythagorean theorem, and you don't have to use sine, cosine, or tangent. So here's a little rule sheet you might want to copy down. Number 1 says a whole bunch of stuff. Basically what it's telling you is that you are going to set the side that's given to you equal to one of the sides I showed you on the previous 2 slides. So if you get the 30-degree leg, you're going to set it equal to x squared root of 3. Step 2 is get x by itself, so you have to solve the equation. Step 3 is once you get x by itself, plug it into all of the other x's in the definition. Take a minute, copy this down. We're going to do some examples. Pause if you need to. Here's your first example. It's a 45, 45, 90. So you look at the 45, 45, 90 definition sheet, and the first leg is x. The hypotenuse is x squared root of 2. And the other leg is x. Those red numbers and letters are the definition triangle I showed you. So step 1 says set the corresponding sides equal. So I set the red x equal to the 5 that was given me. Step 2 is write an equation and solve for x. So we're going to solve this equation for x. Oh my goodness, it's already solved. So step 2 is done. You have x equals. Step 3 is now that we found x, we're going to replace these x's that I'm underlining with that 5. And you're going to get 5 square roots of 2 because we replaced the x. Done. And we're going to get x becomes 5. So my sides are 5, 5, and 5 square roots of 2. So again, whatever side we're given, in this case it was right here, we always set it equal to the side from the definition. Then we write an equation, which I did over here. Then we solve the equation for x. It's done. Then we replug that into the other missing x's that we don't know. So here's another example. Okay, I'm going to write down the definition in red. There's x on a leg, x on a leg, x squared root of 2 on the hypotenuse. So our equation is going to be this right here. So we set it up right there for you. We have x times the square root of 2. Question is, how do we undo multiplication? Because our goal now is step 2. We're trying to get x by itself. We're going to divide both sides by the square root of 2, which I've done right here. These square roots cancel. These square roots cancel, and we get 7. Now that you have 7, you're going to find that x and find that x by replacing them with 7, 7. So our missing two sides were 7. Same process every time. Sometimes the math's a little more annoying. Example 3. Sorry. So again, our definition is x radical 2 on the hypotenuse, x on the legs. So this is the equation we're setting up to solve right now. And good news for us, it's already solved. We have x equals. We don't have to do any math. Now we're just going to replace that with 5 square roots of 2 and that with 5 square roots of 2. So the leg's easy. Hypotenuse, this turned into that. Okay, the square root of 2 times the square root of 2, that's these two right here, make the square root of 4. The 5 stays outside, and the square root of 4 is 2. So we get 5 times 2 is 10. So that missing side is 10. So we have 5 radical 2 and 10. These are exact answers, no decimals. All right, now the hardest one of the bunch. Definition. Now we have 5 on the hypotenuse, x on the leg, x on the leg, x squared of 2. So we have our equation we need to solve. We have to get x by itself. So we go over here and we do this work. And what I'm doing is I'm undoing the multiplication right there with division so that these will cancel and get x. These don't divide out, so we're going to leave them as is. We talked about at the first slide of the day here, we do not, or the second slide, we do not want a square root in the bottom. So to get rid of it, we're going to multiply by the square root of 2. It's going to get that to go away. But we're going to do it twice. So here it is, multiply by square root of 2 over square root of 2. These make the square root of 4, which is, they make the square root of 4, which we already know is 2. These two, when you put them together, they stay, 5 stays outside, the 2 stays inside, and it looks like this. 5 square roots of 2, and the bottom became 2, and this is done. So now we're going to replace these x's with this quantity. 5 square roots of 2, 5 square roots of 2. Here are our answers right there. These are exact answers, no decimals. Now we're going to move on to 30, 60, 90 triangles. The process is the same. Math's a little bit different. So here's one, the easiest one of the bunch. I'm giving you the 60-degree leg. If you don't recall the triangle, I'm about to put the values in red. The 60-degree leg is x, the hypotenuse is 2x, and the 30-degree leg is x squared root of 3. So where are we going to get our equation from? From the 6. The 6 corresponds to which of these sides? It corresponds to the x. So we're simply going to set them equal, and it looks like that. Now we're going to get x by itself, which it is. So this x and this x are going to become 6's. What's the hypotenuse going to become? 12. What is the 30-degree leg going to become? 6 square root of 3. We're done. All exact answers. Example 6, a little bit tougher, not the worst yet. Fill in your definition sides, the 60-degree leg, the hypotenuse, and the 30-degree leg. Always the same. This time we are going to make an equation out of those. So when I solve that, I get x equals 3. That was a pretty easy solve, divide by 2. Now that I know x is 3, I'm going to replace that, and I'm going to replace that with the number 3. Think about what the answer is going to be. I'm going to write them down in a second. The 60-degree leg becomes 3. 30-degree leg, 3 square roots of 3. Finished, exact answers, no decimals. And I have one more example. Toughest one yet. This time I'm giving you the 30-degree leg is 6. So we're going to fill out our definition in red. 2x here, x squared of 3 here. This time we are given these two. This equation is not fun. We're going to set x radical 3 equals 6. And to get rid of the square root of 3, which is being multiplied, I'm going to divide it out. Like that. Ooh, funky. I'm going to do it to both sides, but it's going to look like this when we're done. Sorry, I forgot to write it here. Maybe I should use a different color, but you guys are smart. You'll figure it out. So these divide out to give us x, and these stay as is. We cannot make that 2, 6, and 3 because one's outside, one's inside. But we are going to get rid of the square root of 3. Do you remember how? Well, if you don't, we're going to multiply by the square root of 3 over the square root of 3, which I have in red there. Let me erase that for you. Yep, hopefully that makes it a little bit easier to see. All right, so when we do that, what's going to happen now is the bottom, whoops, sorry, I got to get my pen back out. Okay, down here it's going to become the square root of 3 times the square root of 3, which is 3. And the 6 and the 3 are going to stay separated. It's going to look like that. And now you should see this 6 and this 3 are outside and they divide, and it's going to give us an answer of 2. So we get 2 square roots of 3. So we're going to replace this x and this x. So the 60-degree leg is easy. 2 square roots of 3. The hypotenuse is a little bit more. What's happening here is we are going to get the 2 stays at 2. And we are going to replace the x with, whoops, 2. That was clever of me. So let me put a little parentheses there. 2 square root of 3. That's very nicely done by me. So we have 2 times 2 is, that's where the 4 is coming from right there. 2 times 2 is 4. Leave the square root of 3 alone. We have our answer. No decimals, exact answers, and that's the whole point. And these are how we do. This is probably the toughest thing you're going to see in these kind of problems. So if you understand these slides, you'll be fine. You'll always be. You need to know how to use the red definition triangles, and given a side like 6 in this case, doing the work we did to find out what the other missing sides are, which you need to be able to do. So good luck to you, and just practice and don't give up. You'll get it done. All right, you guys have a great day, and I will see you when I see you. Later.